This is the video for chapter 10.2, hypothesis test for population proportion. Make sure you have your note sheets out so you can follow along here. So we had just finished the language of hypothesis testing. We talked about special terms, the null hypothesis, alternative hypothesis, and it is at the heart of this is that there are claims about the world and we want to test these claims based on some assumptions. We collect sample evidence and then we determine how likely those hypotheses are true or not true. And so that's what we're doing here. So let's start with the first objective here. Explain the logic of hypothesis testing. So let's look at a sample question. Let's zoom in a little bit on that. And so looking at a sample question, a researcher obtains a random sample of 1,000 people and finds that 534 are in favor of banning cell phones while driving. So that means the p-hat is 534 over 1,000. Does this suggest that more than 50% of people favor the policy? Now, the obvious answer would be yes, it does suggest, but this is just a sample. And it's because we're doing a sample, more than likely, we're not sure that's the correct answer. So we want to find a way. One way we could test that is through a confidence interval. But in this case here, we do a sample and we get a value of 0.534. It is greater than 50%, but that doesn't mean the true proportion for the population is greater than or less than 50%. So is it possible that the true proportion of registered voters who favor the policy is less than 50%? And we just happen to survey a majority in favor of the policy? In other words, would it be unusual to obtain a sample proportion of 0.53 or higher from a population whose proportion is 0.5? What is convincing or statistically significant? So in this situation, the idea that if we follow along what we had done before, what we would have here is that the null hypothesis would be that the proportion of people are 50%, and then the alternative in this case would be the proportion is greater than 0.50. That's what we'd be testing. Evidence that this is true. So which one of these could we accept or reject? We have some evidence that this might be true. So something to think about. H1 might be true. Why might it be true? It might be true because we know the p-hat is equal to 0.534. So that's some evidence that it might be true. When observed results are unlikely under the assumption that the null hypothesis is true, we say the result is, and we're going to use this word, statistically significant. And so we would use that word, that's S and that's a G, significant. When observed results are unlikely, when we get something like this, or unlikely under the assumption of the null hypothesis, assuming the proportion is 50%, we say the result is statistically significant. When the results are found to be significant, we reject the null hypothesis. So outlined here are the steps we use to test a hypothesis when we have a situation with a proportion. First, we assume that we can that these conditions are met here. This is what we've been doing before. So we assume these conditions are met. So we have to worry about this here. Okay, so in order for us to actually use a hypothesis test, we talked about the first step after is determining the null and alternative hypothesis, which we did here. And then you decide is it left tail, right tail. In our case, this would be a right tail test. You then determine the level of significance, step 2. Alpha, depending on the seriousness of a type 1 error. So again, alpha. And then in this class, there's 2 approaches. We're going to use the p-value approach to determine whether to reject or not reject this null hypothesis and accept the alternative. And so that's what we would be doing. And we would use technology to calculate the p-value. And then if the p-value is smaller than alpha, the p-value is smaller than alpha, we reject the null hypothesis. Very important conclusion right here. If the p-value that we calculate is less than the alpha, we reject the null hypothesis. Let's go ahead and fill in a couple of things here. We will not be doing the classical approach. We'll be doing the p-value approach. And in this case here, we can fill this in for now here. So in the classical, if the sample statistic is too many standard deviations away from the proportion stated in the null hypothesis, we reject the null hypothesis. That's our conclusion. Given what's the definition of p-value? Well, we definitely need to know this. The p-value, when you calculate, is a probability. It's the probability of observing a sample statistic as extreme or more extreme than the observed one under the assumption that the statement of the null hypothesis is true. And so we're looking for the likelihood, basically, that the alternative hypothesis may be true, and that would be the p-value under our given assumption. And on the p-value approach, if the probability of getting a sample statistic as extreme or more extreme, statistic as extreme or more extreme than the one obtained is obtained is small under the assumption the statement of the null hypothesis is true, we reject the null hypothesis. And a phrase where I'm going to say, if the p is low, the null must go, which means we reject the null hypothesis. So let's go ahead and do our first example here for this. So that would be a phrase we use. So let's go ahead and actually run a hypothesis test and get an idea of what we're going to do. We have the steps here that we need to refer to. And so step one is we're going to assume all the conditions are met as outlined here. Okay, these steps are met. Let's go ahead and write the null hypothesis and alternative. In 1997, 46% of Americans said they did not trust the media when it comes to reporting news. That was 1997. In 2007, a poll of 1,010 adults nationwide, 512 stated they did not trust the media. At the alpha 0.05 level of significance, is there evidence to support the claim that the percentage of Americans that do not trust the media to report fully or accurately has increased since 1997? So we're trying to see, is our 2007 value more than the 1997 value? So in this case, what we have here, first we need to calculate p-hat at some point. P-hat is going to be 525 divided by 10 over 10. That's going to be an important value for us. Okay. We then need to identify the null hypothesis. The null hypothesis, and again, is that the proportion is equal, has not changed. It's 0.46. The alternative is that the proportion now has increased. It's greater than 4.6. What evidence do we have that the alternative might be true versus the null hypothesis? Here's our evidence. 512 divided by 512 divided by 10,000. Let's do that again. 525 divided by 1,010. That is our sample statistic. When we get that value, you get 0.5198. Or I guess we should round that to 0.520. 0.52. 0.52. So this could be evidence. This could be evidence that H1 could be true. Okay, that's some evidence, but let's go ahead and test it. Step 2, we are testing this at the alpha equals 0.05 level, so that's important to know. The next thing we want to do is go ahead and calculate step 1. We have the level of significance, and then we now go ahead and calculate the test statistic. Now we're not going to use this. We're not going to. This is the form we would do by hand, but what we're going to do, we're going to calculate the test statistic. And so in this case, this was our first step. Second step, third step is to calculate the test statistic. Instead of doing that by hand, we're going to use StatCrunch. So you're going to open up StatCrunch, stat, proportion stats, one sample with summary data. And so the number of observations 525 over 10, 0, 1's 10, 10. And we're doing a hypothesis test. P is equal to 0.46 and P is greater. So once you set that up, again, how did that come from? Where did that come from? That comes from this setup right here. Here is our setup right in here, right? With those values there, alpha 0.05. Let's go ahead and run the test. We get a test statistic. There we go. The z-stat is 3.813. 3.813 is our test statistic. 3.183 is our test statistic. From there, step 4 is to go ahead and get the p-value. So here is probability that that z-value is, the probability that the z-value is greater than 3.183 is what we're testing. There's our p-value. And on this case, let me put that back. It's not right. That is the probability. The p-value is going to be equal to p-value is equal to, in StatCrunch it has it. P-value is less than 0.0001. It's a very small number. P-value is 0.0001 or smaller than that. And so step 4 is to decide, since the p-value is smaller than alpha, and those p-values are 0.0001. This is 0.05. Since the p-value is smaller than alpha, we reject the null hypothesis. We reject, which then means we're saying this is not true, and we're rejecting this and saying we're going to say that this is more than likely true. Since we have that evidence, it kind of bears out for us. Step 5 is then to state a conclusion, which I don't have. Step 5 is to state the conclusion. We need to recall from 10.1 how we state a conclusion. To state a conclusion, right here. To state a conclusion, the conclusion to a hypothesis test is always as follows: there is or is not sufficient evidence to conclude that, and insert the statement in the alternative. So in this case, there is sufficient evidence. So step 5 is to write the conclusion. We're going to say there is sufficient evidence. There is sufficient evidence to support the claim. That, and again, where am I getting that language from? Right up here. To support the claim that. So I'm using that information there to support the claim that the proportion, the population proportion is greater than 0.46, right? That the population has been increasing. So that would be our conclusion. That's how we run a hypothesis test. Go through the process where we use StatCrunch right here. Let me make a note one more time. You get these values from StatCrunch. These values come from StatCrunch, okay? So that's it. Let's go ahead and might as well finish this off. Let's go ahead and do another hypothesis test here. Two major college entrance exams that a majority of colleges accept for student admissions are SAT and ACT. ACT looked at historical records and established 22 as the minimum ACT score for a student to be considered prepared for college math. Being prepared means that there is a 75% probability of successfully computing college algebra in college. An official at the Illinois State Department of Education wonders whether less than half the students in her state are prepared. There is that right there. An official from the state wonders whether less than half the students in her state are prepared for college algebra. She obtains a sample of 500 records of students who take the SAT and finds that 219 are prepared for college math. Does this represent a significant evidence that less than half the students are prepared for college? So let's go ahead and start. We have a p-hat in this case. It's going to be, so this is our sample statistic. This is going to be 219 over 500. In this case, that equals 0.438. So maybe there is some evidence to suggest that less than half the people. The null hypothesis is going to be that the proportion equals 0.50. The state person believes that the proportion is actually less than 0.50. This is evidence, potentially. This is evidence for H1 could be true because the sample is smaller. So that's step one, get the null hypothesis. Her claim is that it's less than 0.50, less than half her students are prepared. Step two, after step one, step two is to go ahead and select alpha level. In this case, our alpha level our alpha level is 0.05. So now we know what we're going to be comparing our p-value to. So in this case, alpha equals 0.05. Step 3 is to calculate the test statistic. And we're going to do that again with StatCrunch. I got some values, 219 over 500, 0.50. So in here, we go ahead and put 219 over 500. We're going to do a hypothesis test. This is 0.50, and that it is less than 0.50, and then we run it. And you get this here. You get a negative 2.77, negative 2.77. So I'm looking at this values right here. Those are the values I'm looking at. Negative 2.77 is my z. Negative 2.77. And the p-value that we get from StatCrunch is 0.0028. So now step 4 is to compare them. And then since the p-value is smaller than alpha, this p-value is 0.0028, this is 0.05. Since the p-value is less than alpha, we reject the null hypothesis. We reject. When that happens, we reject. Let's fix this. Erase, 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 erase. We reject the null hypothesis. So we're saying this is not true, and we're saying that's true. Step 5, put the conclusion. The conclusion here is going to be there is sufficient evidence to support the claim that less than half of the students are less than half the students are, what does she say? Half the students are prepared for college math. Less than half the students are prepared for college math. So we have evidence to suggest that that is true based off of the p-value. Let's finish this up. Last one here. StatCrunch again shows you how to do that, which I've been doing. Last one here. When asked the following question, which do you think is more important, protecting the rights of Americans to own guns or controlling gun ownership? 46% of Americans said that protecting the right to own guns is more important. The Pew Research surveyed this many people, and this many people said believe that protecting the right to own guns is more important. Does this result suggest the proportion of Americans with at least a bachelor's degree feel differently than the general population? So again, when asked the following questions, which do you think is more important, protecting the right of Americans to own guns or controlling gun ownership? 46% of Americans protecting the right to own guns is more important. The Pew Research surveyed 1,267 randomly selected Americans with at least a bachelor's degree. Okay, so here we go. You start with your p-hat is going to be 559 all over 1267. Our null hypothesis is that the proportion who believe that is 0.46. The alternative is, does this result suggest the proportion of Americans with a bachelor's degree feel differently? And so in this case, feel differently means not equal to 0.46, which is a two-tailed test. That's step number 1. Step number 2, at what alpha level? We're going to use alpha equals 0.10. Step number 3, we have to get the test statistic and p-value. And so you go ahead, we run that, and our values are, let's check real quick, 559 over 1267. 559 over 1257 or 67. Double check. 1267. Make sure I get that right. And then null hypothesis 0.46 and put not equal to. So that means it's different than. Compute. Get a z of negative 1.34. Negative 1.34. And so you get negative 1.34. Your p-value is not small, it's not low. And so in this case here, 1794, your p-value is 0.1794. Step 4, what do we say? Since the p-value is greater than alpha, we fail to reject the null hypothesis. So that means we're essentially saying this is not true, and we're going to accept the null hypothesis. And in this case, then we're going to conclude, since we failed to reject, that's important, failed to reject. In this case here, what we're going to end up doing is saying there is not, because we're failing to reject, sufficient evidence to support, not sufficient evidence to support the claim that Americans with bachelor's degrees, that the proportion of Americans so long conclusion with at least a bachelor's right here feels different. There's not sufficient evidence for this. Feels different than the general public. That's it. Have to practice this more. Hypothesis testing.